Hello, everyone, all of you. Good morning. My name is S.A. Patil, Department of Physics, Lakshmi Education Trust, Gokak. Dear students, today now I will discuss about that BSc second semester subject physics. Now we are going to discuss about that syllabus on the screen. See here, first unit is vector analysis. Then part of the vector analysis, the part is Maxwell's electromagnetic theory. The first unit is the total 15 hours syllabus. Then second unit is DC circuit analysis. Then part is transient circuits. This is also 15 hours syllabus. Then third unit is magnetostatics, then the part of magnetic properties and part of electromagnetic inductions and part of alternating current. This is also 15 hours syllabus. Lastly, fourth unit, that is the electrical instrument and part of dielectrics. This is also 15 hours syllabus. Dear students, now we are going to discuss about, that is the first unit is, that is the name of first unit is vector analysis. The vector analysis, including the some part of the points, scalar and vector products, then gradient of scalar and its physical significance, and divergence of vector and its physical significance, then curl of vector and its physical significance, then vector integration, line surface and volume integral of vector field, Gauss divergence theorem and Stokes theorem, and then lastly statement. Then part of Maxwell's electromagnetic theory, derivation of Maxwell equation of differential form, mention of Maxwell's equation in integral form and their physical significance, derivation for general plane wave equation in free space. Lastly, transverse nature of radiation, derivation of Poynting theorem. This is the important in the examination for the derivation of Poynting theorem. This is 5 marks important questions. Okay, then now we are going to discuss about the vector analysis. Dear students, what is vector analysis? Okay, what is vector analysis? Now discuss about the vector analysis. Firstly, the physical quantities are divided into two main classes. First one is the scalar quantities or scalars. Then second one is the vector quantities or vector. This is the vector analysis. That is the physical quantities are divided into two main classes. One is scalar quantities, then second one is the vector quantities. First one is the scalar quantities. Physically quantities which have magnitude only but not associated with the direction or orientation in space are called the scalars. What is scalars? Physical quantity which have magnitude but not associated with direction or orientation in space called scalars. Such a quantities are specified by their numerical value and dimensions. For example, scalars are the mass, volume, density, temperature, energy. There are so many part of the this example for the scalar quantities. This is the main important points are the scalars are the mass, volume, density, temperature and energy. This is the very best example for the scalar quantities. Scalars are manipulated elementary operators, namely this is addition, subtractions, multiplications and division. These are the operators, elementary operators in the scalar quantities. All these the mathematical operations. Okay, this is the addition, subtraction, multiplication and division. These are the mathematical operations with scalars. Obeys the rules of ordinary algebra by means of certain laws given below. First laws is the association, laws of association. What is the laws of association? According to this law, the sum of product of finite number of scalar. What is the according to law of sum of product of finite number of scalar is independent of the manner in which they have may be grouped or associated. For example, a plus b plus c, this is equal to a plus bracket of b plus c equal to a plus b plus c equal to bracket of a plus c bracket close plus b, and a of bracket bc equal to bracket of ab c equal to bracket of ac b. This is the product of finite number scalar, or sorry, sum of the product of finite number with the scalars independent manner of the grouped or associated. This is called as the laws of associations. Okay, my dear students, then second law is the commutation. What is law of commutation? What is law of commutation? It states that result of addition or multiplication of number of scalars, the result of addition or multiplication of number of scalars is quite independent order which they may be taken. This is called as law of commutations. Okay, now it's clear. Okay, then third law is law of distributions. What is distribution? It be addition or multiplication. Distribution means the addition of distribution, addition or multiplications. Okay, a cross b plus c equal to a cross b bracket plus a cross c. Then a plus b cross c equal to a cross c plus b cross c. That is the addition and multiplications of number of scalars quite independent order. This is called a law of distributions. For the best example for the distribution. Then vector quantities. First one is the scalar quantities is completed. Then second quantity is the vector quantities. What is vector quantities? Many physical quantity which have magnitude as well as direction or orientation are called vector quantities. For example, vector quantities are the moment of inertia, acceleration, force, velocity, displacement, momentum, magnitude, magnetic inductions and magnetic identify. There are so example for the vector quantities. These are the best example for the moment of inertia, acceleration, force and velocity, displacement and momentum. These are the best example for the vector quantities. Already I have to study it is the moment of inertia, acceleration, velocity and displacement, momentum. Okay, vector quantities is a reason which is vector quantities varies from the point to another point. Okay, vector quantities reason in vector quantity varies from one point to another point. The concept of vector field can easily be understood with help of following examples. First one is a consider body which is rotating about an axis. Okay, she's dear students, assuming a body which is rotating about an axis, the velocity of the body is different at different points, means the moment of inertia or angular momentum. Already have studied the angular momentum. The body which is rotating about an axis, the velocity of the body is different at a different points. The velocity is in function of position of the point, hence velocity is, that is the vector field. Okay, then second one example is, consider the heat flow through a block of material whose forces are maintained at different temperature. There will be flow of heat from heat part of the block to the holder part of the heat will be following in different direction in different part of the block. This heat flow is a vector field. Okay, then vector triple product. Then new concept is the vector triple product. If a vector, b vector, c vector or any three vectors, then a vectors cross into bracket b cross c bracket complete, or a cross into b vector into c vector are called vector triple product. A vector, b vector, c vector, these are the three triple product of the vector. Okay, now we know that that is the d, that is the gradient vector. Gradient vector, that is u equal to I into I vector I cap du divided by dx plus j cap du divided by dou y plus k cap dou u divided by dou z. Then the common is, that is the u is the gradient vector is common, then the gradient or triple vector x y and z or I j k, these are the triple product of the vector. Okay, then gradient vector u equal to I cap du divided by dx plus j cap du divided by dou y plus k cap du divided by dou z. Then I cap d divided by d dou x plus j cap d divided by dou y plus k cap dou divided by dou z into gradient vector u. The term, the bracket is called, that is the gradient. The dou has the meaning it just like dou by dou x until it is associated with some function to be different depth. Then we call a vector operator, the vector operator equal to I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. The operator, the gradient vector or operator on scalar as well as vector, there are two useful operation. One is called the divergence of vector and the another one is the curl of the vector. Then scalars and scalar quantities and vector quantities are the completed. Then the scalar and vector product, and then second point is the gradient scalar and its physical significance. Now we are going to gradient vector of scalar and its physical significance. Okay, okay, dear students, a new concept is the gradient of scalar field. Okay, in order to consider gradient vector of scalars, let psi of x, y, z be the scalar functions of position of scalar point of coordinates, that is the x, y, z. These are the scalar point of coordinates. Okay, the partial derivatives of psi along the three coordinates axis are dou xi divided by dou x into dou xi divided by dou y and dou xi divided by dou z. This respectively, these are the scalar point of coordinates and partial derivatives of the xi along the three coordinates axis. The gradient of scalar function, that is the xi, is defined as gradient xi equal to I dou xi divided by dou x plus j dou xi divided by dou y plus k dou xi divided by dou z. We know the differential operator gradient or del is defined as, that is the del is defined as del equal to I cap dou divided by dou x plus j cap dou divided by dou y plus k cap dou divided by dou z. The del into xi equal to I cap dou psi divided by dou x plus j cap dou xi divided by dou y plus k cap dou xi divided by dou z. The gradient is a differential operator by means of which we can associated a vector field with scalar field. For example, the intensity of the electric field E a vector quantities. The intensity of the electric field E is the, that is the vector quantities, is a gradient of potential, velocity, phi and scalar quantities with negative sign indicate that energy equal to or electrical field equal to minus gradient vector phi. That is the electrical field equal to minus gradient vector phi. This is the negative sign indicates, means the scalar quantities gradient potential vector. The negative sign indicates that the direction of field intensity in opposite direction in increase the potential. That is the opposite, the direction of the increase the potential is called the negative sign indicate that. Okay, then this is the gradient of scalar field. Then new concept is formula and physical significance of the gradient of scalar field. Okay, this is, see here diagram. The scalar field can be mapped out by the series of level surface. Consider two such a surface very close to each other as shown in the figure. See here diagram. These surfaces are specified by constant scalar functions s and respectively std s. These are the respectively. Let a, that is the circle, that is the a center of the point, that is the a and b are the 2 points of the surface. Okay, o is point outside the surface and let r be the r be the radius of vector or radius of the vector point. A and b with respective origin, a and b are the with respect to the origin. Okay, then vector drawn a to b, then the vector from a to b will be, that is the distance is dr. Okay, therefore a b equal to o b minus o a equal to distance is r plus dr minus r equal to dr. AB distance is dr, then OB distance means r plus dr. OA distance is r vector, that is equal to total AB equal to dr. Then let us the normal drawn from the point A, the normal drawn from the point A of the surface yes is AC and is the unit vector along the normal, the unit vector along the normal. Now the certainly AC will be minimum, the AC will be minimum distance between the two surface. Suppose the angle between AB and AC is theta. The angle between the AB and AC, the is surface angle between the theta. Now the magnitude of the rate increases. The magnitude of the rate of increases of S. The magnitude of the increases rate of S at the point A in the direction AB is dou S divided by dou R. Similarly, the rate of increases S, the rate of surface that increases S in the direction AC is dou S divided by dou N from angle of ABC. Then AC equal to AB cos theta, then dN equal to dou R cos theta, dou S divided by dou N equal to dou S dou R cos theta, or dou S divided by dou R equal to dou S dou N divided by dou N cos theta. This is equation number 1, where ds divided by dr is maximum when theta equal to 0, because now cos theta equal to 1, so their maximum value of dou s divided by dou r is dou s divided by dou n, then dou s divided by dou n into n cap, where n cap is the unit normal vector at the point. The vector is defined as the gradient of the scalar field at that point. It is the written as, that is the gradient S surface, that is the gradient S equal to dou S divided by dou n into n cap. Okay, this is the formula and physical significance of the gradient of scalar field. This is 5 marks important questions. Okay, then this is for the example for the if. Okay, dear students, you have to solve the problems. Then the next part is divergence of vector field. Okay, divergence of vector field. First one is the divergence of vector field at any point is defined as the amount of flux per unit volume diverging from that point. The divergence of vector field at any point is defined as amount of flux per unit volume diverging from that point. Let a be vector function differentiable at each point, that is the coordinates x, y, z in region of space. Now the divergence of A is given by the del into A equal to I into dou by dou x, that is the vector field, plus j cap dou by dou y plus k cap dou by dou z into I cap ax plus j cap ay plus k cap az. Then del into A equal to dou into ax divided by dou x plus dou into ay divided by dou y plus dou az divided by dou z, that is the ax, ay and az, then dou x dou plus dou y plus dou z. Then divergence of A equal to del into A equal to dou ax plus ay plus az. This is the divergence of vector field. This is also 5 marks important. Okay, next one is physical significance of divergence. Okay, the physical significance of divergence of vector field is that of point it gives amount of flux per unit volume diverging from that point. For example, if vector represent the velocity or of fluid, liquid, or gas, therefore A equal to phi, then divergent phi given rate of flow of the fluid at the point per unit volume. Okay, this is for the example. Then curl of vector field. Okay, first one is the divergence of vector field and the physical significance of divergences. Okay, then curl of vector field. The curl of vector field is defined as the maximum line integral of vector per unit area. If A is vector function differentiable at each point x, y, z in a region of space, then the curl or rotation of A expressed by the cross product of del and A. Curl A equal to del into cross A equal to I j k dou by dou x dou by dou y dou by dou z ax ay and az mod. The physical significance of curl in general, or the general meaning of curl is rotation. When curl A is 0, it means that no rotation attached with the vector A, whereas the curl A is the non-zero. It means that rotation is attached with vector A. This is the diagram. See here diagram, dear students. Okay, consider the flow of liquid. Okay, flow of liquid, frictionless foldable is placed in the path of liquid flow if we assume the all the liquid layers are the moving with the some velocity. Okay, the pedal will not rotate it. Thus shows the curl of velocity vector is 0, means the velocity of the pedal will be not rotate when that is the path of the liquid flow in the assume liquid layers are the moving at some velocity. Okay, then second one is the if consider the liquid layers are the moving at different velocity. Okay, then the pedal will rotate rotation due to non-zero value of the curl of the velocity of the vector. Okay, then lastly different type of vector field. Okay, first one is the field having no divergence and no curl. Then second one is the field having divergence and no curl. Third one is field having curl and no divergence. Then fourth is field having curl and divergence. Okay, first one is the field having no divergence and no curl. In this case, del into A equal to 0 and del cross A equal to 0. This example of such a fields are study states that flow, electrostatic field, gravitational field. Already I have studied electrostatic field, heat flow and gravitational field, irrotational motion of the compressible ideal fluid. There are so many examples for the field having no divergence and no curl. Okay, then second one is the field having divergence and no curl. In this case, del into A, this is not equal to 0, but del into A equal to 0. Field having divergence and no curl. Here gravitational field inside the mass, electric field within volume, distribution of charge, time independent Schrödinger wave equation. This is called the field having divergence no and curl. Third one is field having curl and no divergence. Del cross A is not equal to 0, but del into A equal to 0. Such a fields are magnetic field due to the steady current in compressible fluid with velocity. Then so many examples for the having the curl no divergence. Then lastly, fourth one, field having curl and divergence. Del into del cross A is not equal to 0 and del into A is not equal to 0. The Maxwell's equation within matter or example for such a field is. Okay, these are the fourth different type of vector field. Last one is the vector integrations. Okay, vector integrations, the vector algebra, the integral which are commonly used are first one is line integral, second one surface integral, then third one is the volume integral. Okay, my dear students, now I will stop it. Tomorrow I will discuss about the some line integral, surface integral and volume integral. Okay, thank you my dear students.